Hey guys, okay, we're going to do the video for 1-3. Alright, first we're going to do a little bit of review for 1-2. Alright, so what I got here is the 5 postulates. 5 postulates. Alright, we talked about them yesterday, and what they are is they're talking about how we could use the parts of a triangle to figure out if it's congruent to another. So, for example, side, side, side says, right, that I have 3 congruent sides in each triangle that says that they're congruent. So, like this side is congruent to this side is congruent to this side, and this side is congruent to this side. So that's how I know that this triangle and this triangle are the same. Okay, here I have side, angle, side. So this is a side, is congruent to here. This angle is congruent to this one, and then this side is congruent to that side. Okay? All right. Now, let's take a quick look at this part here. All right, we got triangle, right, BAC, right, and we got triangle DEF. Okay? So these triangles are congruent by angle, side, angle, angle, side, angle. All right, and what we could do is we can say that they're congruent, right, by angle, side, angle, and I can make this statement here, that triangle BAC is congruent to triangle DEF. Okay, that's supposed to be an E there. All right, so, and that order is important. You have to recognize that order is important. So that's kind of why I put this out of order. That angle B is congruent to angle D, and angle A is congruent to angle E, and angle C is congruent to angle F. That also works with the sides, which you just watched me erase, but I'm going to rewrite it. So BA is congruent to DE. Okay? I could say that. I could also say that AC is congruent to EF. And BC is congruent to DF. Okay? We could say those things. I could also say that angle B is congruent to angle D. Angle A is congruent to angle E. Okay, one more point we got to get to before I can start 1-3. All right, I got here a pair of parallel lines. I'm telling you they're parallel. Okay, and this line here that's cutting through these parallel lines is called a transversal. Inside every set of parallel lines exists these angles. All right, and these angles are called alternate interior angles. And you need to make the association that when you see parallel lines, okay, sometimes they're marked with an arrow in them, right? When you see these parallel lines, right, you're going to have alternate interior angles. All right, so let's take a look at the first example. Okay, so the first example, right, there we go, says, given the diagram below, are triangle ABC and triangle DCB congruent. All right, so we want to prove that these are congruent, but also I got to back it up with facts. All right, so right now I only have 2 congruent parts. That's what the picture gave me. Okay, I have an AB that's congruent to CD, and I have angle ABC that's congruent to DCB. Okay, if you look at these, right, we got side, side, side. That is 3 parts. Side, angle, side, 3 parts. The only postulate that does not require 3 parts to prove is HL, okay? Which is down here at the bottom. So, now, right, what we're going to do is we're going to prove that this triangle is congruent. Well, what I have is I have a shared side here. Okay, so now I can make the statement, right, with that piece, I could say that triangle ABC is congruent to triangle DCB. Okay, and I can say that's happening by side, angle, side. Look, it happens here too, side, angle, side. Side, angle, side, side, angle, side. Okay, so we're going to say side, angle, side. Now I have to back up what I said with facts. Okay? And I have the facts, right? We had them here all along. So AB is congruent to DC. I'm going to write AB is congruent to DC. I know that because they told us, or they gave it to us. So I'm going to say it's given. Okay? Then angle DCB is congruent to ABC, angle ABC. I know that because they told us that. Alrighty, so that is also given. Then the last part, which we figured out, was that CB, so side CB, is congruent to BC. Notice I switched it. I switched it because this side applies to this triangle and this triangle. Okay? And I represent such by changing the order. And we said that that was a shared side. Okay, so I made this statement here. Here's my statement. And here are my reasons. Okay, to back it up. To back it up. All right, let's do the next example. Next, we got example 2. Well, example 2, okay, if we take a look here, it says, given the diagram below, are triangle ABC and triangle DCE congruent? Okay, so is triangle ABC and triangle DCE congruent? Well, let's take a look. Okay, I've mentioned before how important the order is, right? We talked about that. Okay, so let's take a look at the order here. A, B, C, D, C, E. All right, let's take a look at that again. A, B, C, D, C, E. So if I number it, it becomes pretty clear that my order is not the same. That's angle 1, 2, and 3. Right? I did this 1, 2, and 3 like that. 1, 2, and 3. So this is 1, 2, and 3. You see the way these guys here don't match up? Okay, so this is not congruent. All right, we are not congruent here. And we're not congruent because the angles don't line up. All right, so we don't have that congruency that we're looking for. All right, last example. Okay, the last example here, right? We want to prove that triangle ABC and triangle EDC are congruent. So let's take that previous example and make sure that everything's in order. All right, so I have triangle ABC and triangle EDC. ABC, EDC. Looks like it might be slightly different, so I'm going to put my numbers in there. 1, 2, and 3. 1, 2, and 3. Okay? 1, 2, and 3. 1, 2, and 3. All right. So at first glance, it looks like they're not, but in fact they are. Look at the way the 3's match up, right, at the vertical angles. So we're in good shape. Now, if we look back at our example from before, okay, I pointed out to you guys that parallel lines, okay, parallel lines produce alternate interior angles. And you can see here that we have these arrows. Okay, well, let's take a look here. The arrows, they're right here. So what that means is we're going to have alternate interior angles that exist inside. Here is this one and this one. Coincidentally, look at the way they're numbered the same. Okay, then this guy and this guy. These are both alternate interior angles. Now, with that being said, right, I can make the statement that these are in fact congruent, right? And I could say that is the case because this is angle, side, angle. Angle, side, angle. And now that's my statement. Let's back that up with some facts or some reasons, okay? Like we mentioned, right? It's important that you back up any statement you make with facts. So I know that angle A is congruent to angle E. All right, I'm going to use the letters. So I'm going to say angle BAC, right, is congruent to angle DEC. And we know that is because these are alternate interior angles. You can abbreviate this to AIA if you like. All right. Next, I know that AB, side AB, is congruent to ED. And that is because they told us. So it's given. All right. I'm going to kind of try to separate these. Right. Next. Right, I got my last set of angles. So I mentioned this angle. Look, angle, side, angle. I mentioned an angle. Here's my side. Next, I got to mention another angle. All right, so this is my side, and now I'm going to mention the other angle. All right, the other angle is EDC. Triangle EDC. Angle EDC, sorry. Angle EDC. And angle ABC. Okay. Angle ABC. I keep underlining the vertex for you guys so you can see the difference in the angles. And this is alternate interior angles as well. Okay, guys, that's how we make statements and back them up with facts. I hope you found this video helpful.